Hi everyone, this is Preeti Raghunathan. So, my digital forensics project is called Sumup. It was initially meant to extract all possible data that a forensics investigator would be interested in and provide the output as a HTML report. But I started with file analysis because the first thing we do when we get a disk image is go through the files, see if there's anything suspicious in the files, and so on. So I started automating the TSK output. So while doing this, SumUp somehow just became a good user interface for TSK, and it actually is a good interface for TSK, this loop kit. So let's take a look at its execution. So Python sumup.py. All you have to do is execute the Python program. So let's give it a place to store the output. And a sample test case name. A sample name for the case. So in my case, I'm giving test case. And then we enter the path for the disk image that we are going to look at. So this is the disk image we're going to look at. It has been downloaded from this link, which will be available in the references in my report. So we also have a feature which will verify if the disk hasn't been tampered with, the disk image hasn't been tampered with. That is done by providing it the hash, either the MD5 hash or the SHA-1 hash. So over here they've given the MD5 hash. So once this is done, the output is going to be generated in the specified address. As you can see, we have test case. Extract will have all the files extracted from the disk image, while HTML contains our HTML files. We don't have to look through each one of these, just look for a report.html file, and from here we can traverse to all the other files. So this is the file system information, and we have the file analysis, which is looking at all files, deleted files, existing files, or we can even take a look at the directory structure. So over here, directory 1 is a folder which has directory 2, and directory 2 in turn has frag3.dat. mul2.dat belongs to directory 1. So these are used to tell us which directory the files belong to. So this is the directory structure. There's a back home button, so it'll take you back to the home page if you want to check this out, or the file system information. And as you can see, the given disk hash is here. That is what we gave. And then these are the MD5 and SHA-1 computed hashes. So if this is going to be different, then it's going to say image is corrupted. Over here, since it's the same, it says image is not corrupted. So all the files have the FLS command output in a table format, and their metadata extracted based on inode. Also, we have the file type, the MD5 hash, the SHA-1 hash of the file, everything that we need or we usually look at. So let's just take a small look at the deleted files to see if we got it right. So as you can see, there are supposed to be 6 deleted files and 2 deleted directories. So we have 4 files, and the rest of the files and directories come under one single directory. So as we can see here, it displays those 4 files and that single directory. Since everything comes into this directory, it's right. So yes, that's it. That's it for my tool. This makes I feel that this is a good interface for SleuthKit. Also, since we have a HTML report from this tool, and we don't have to keep it running because there's no server, we can easily just take up the HTML report, back it up for evidence, or you just run it through other systems for analysis if your system is bad. And that's it. So this is my tool. Thank you for taking the time to listen to my presentation. So when you guys are giving, if anyone has any comments about the tool, how I can develop it further, what more functionalities I could add, please feel free to let me know. It'll be nice if I could, so the future scope for this would be that I do include automate everything that we may need from the disk image and place it out as a proper report, so that all a user has to do is just go to the information, the piece of information they need, and maybe even have a functionality there that could generate case reports. So there's a lot of options that we can do with this tool. And it's easily modifiable. It's just one Python program, so I'm pretty sure there's a lot we can do with the tool. Thank you so much for listening. That's it.